On to day 2 of section 2.1, the derivative, and today we're going to define the derivative using the limit definition. And you'll notice that this box looks very similar to the one that we did on day 1 of this 2.1 introduction to the derivative. The derivative of a function is noted by f prime of x, and f prime of x, sorry about that, is, I need to write it. I'll write it out for you. Is the limit as h goes to 0 of f of x plus h minus f of x all over h. And that's the one we're going to be using today. Yesterday we experienced this particular format of f prime of a, where a was some point. Maybe we were looking at x equals 2. And so we evaluated our function at 2 to get the derivative. Once again, reiterating, a function is differentiable at x if the derivative exists, which means that this limit has to exist. A function is differentiable on an open interval a to b if it's differentiable at every place in this interval, okay? The derivative of a function is itself a function that can be used to find the slope of the tangent line at any given point x, f of x. So not only are we handed a function, but when we go and find the derivative, it too will be a function. Okay, so first step here is, I think we had 3 problems to work through today. I'm going to start with a very simple one, sort of similar to the one we did yesterday. It was linear. For today, this is another linear function. I can predict that f prime of x is going to equal -5, because looking at a linear function, we know what the slope is. It stays consistent throughout that function. Unlike a parabola, where if I graph a parabola, I have tangent lines along here with slopes changing, right? They have different slopes all along here. So this has varying slopes, whereas a linear function has a maintains a slope maybe of 2 here, okay? Just to talk about the difference between a linear function and a quadratic in respect to what we expect to see on its derivative. So let's go through with this process. F prime of x is equal to the limit as h goes to 0 of f of x, I'm sorry, it's at f of x plus h. So I'm going to take -5 and I'm going to plug in everywhere I saw an x up in this function, an x plus h. So replacing it with x plus h and completing the rest of that function, which was to add 7. Then if I look back up, I'm just going to have to scroll up. Here's my function. I did the first part at f of x. Now the second part, whoops, got to go further up. I did the first part at f of x plus h. Now the second part is to subtract f of x. So coming back down here, I go into subtraction of f of x. I need that parenthesis because of the subtraction sign, and I have more than one term I'm bringing on with my f of x function all over h. If it would be helpful, you may want to just say, as a reminder, this was my function f evaluated at x plus h. Then I subtracted just f of x. So that's where we came up with those terms. From here on out, it's going to be a lot of algebra. And I think I'll take my -5 and distribute it through. And I'll also take this negative and distribute it through, so I get a positive 5x and a -7 over h. So on top we have -5x minus 5h plus 7 plus 5x minus 7. And you maybe already have taken a glance. I have a positive 7 and a -7 adding to 0, a -5, a positive 5 adding to 0. This leaves me quite a nice limit the limit as h goes to 0 of negative 5h divided by h. If I try to substitute in 0, I get 0 over 0, which is not helpful for me right now. But I also noticed that I could take and just reduce h over h, and h divided by h gives me 1. So I have negative 5 times 1. For a final answer of negative 5, that will be my f prime of x. Not a big surprise, because we knew this function was linear, and right in the front here, we know that the slope throughout the linear function is negative 5. Okay, so now that we're warmed up, we can really hit it here. Find the derivative of the function f of x equals 2x squared plus x minus 1, and they ask us to evaluate it at x equals 4. Now yesterday, we did this using f of x minus f of a. I would have put in 4 over x minus 4. And I would get my derivative at 4. It only applies then at 4, so it's somewhat limiting in what I can do around 4. I can't go to 6 and say, well, then what's the slope at 6? With this other process that we're doing today, notice that this has the variable x in it. This is a more general derivative expression, because that's going to be in terms of x, and then I can decide what I want my x to be. When I come out of this problem, I'm going to say, well, what's happening when I'm at x equals 4? So here we go. Let's start it out. F prime of x is equal to the limit as h goes to 0 of f of x plus h. So everywhere I see an x, right there's one and right there's one, I'm going to replace it with x plus h. So on top, I'm going to go 2x plus h quantity squared plus x plus h minus 1. And for that, I was replacing x. The next step is to subtract f of x. Well, f of x is this function as it's shown, 2x squared plus x minus 1. Not forgetting to put parentheses around that, because of this negative sitting out in front of my group I was supposed to subtract, all over h coming from the formula. It is now set up, and we're ready to go ahead and do the algebra involved. The limit as h goes to 0. I'm going to square this out, and remember, squaring will look like this, x plus h times x plus h. We know we multiply the first, which gives us x squared. We'll multiply the last, that gives me h squared. And then I get the combination of the inner and outers. And that'll give me a plus xh and another plus xh, or hx. Grand total in the middle is 2xh. So I'm going to have 2 times x squared plus 2xh plus h squared, plus sign down there. Then I'm on to this, plus x plus h, parentheses not really needed there, minus 1. Let's take this negative, send it through to the 3 terms of f of x. And that will look like negative 2x squared minus x plus 1 divided by h. Cleaning up. Actually, I think I have one distributive step to go yet, don't I? We got to send this 2 through. And that's going to look like 2x squared plus 4xh plus 2h squared plus x plus h. Let those parentheses disappear. They weren't really serving any purpose there. Copying the rest of that down all over h. Now take a pause and take a big look at this. We have some positive and negative offsetting each other. Negative 2x squared plus the positive x squared makes 0. A negative x with a positive x, backwards, that gives me 0. A negative 1 with a positive 1 gives me 0. And we've got this down, so we just have a few terms now. So rewriting this, let me move this out of our way. Rewrite. Let's update the limit as x goes to 0, or h goes to 0. We have a couple terms sitting here. I have this, this, this remaining. So 3 terms in total. 4xh plus 2h squared plus an h all over h. Are you noticing that they all have an h in common? Let's GCF that. The limit as h goes to 0, I would have h pulled from those 3 terms. Makes it look like that. H canceling h, or h divided by h makes 1. Now let's evaluate our limit by substituting 0 in for our h. That can get replaced with 0 because we're taking the limit as h goes to 0. So that leaves me 4x plus 2 times 0 plus 1. Remembering this was our h, right? And final answer is f prime of x is equal to 4x plus 1. Notice how this is different than what we got yesterday. Yesterday, when we were evaluating at a number, we actually got a numeric value out. This is referred to as a general form of the derivative for this particular function f. I can get specific if I want to evaluate it at a point, and I do want to evaluate it at a point. This question asks, what is the slope when we're at 4? So we'll come down here and evaluate when it is 4, and I do nothing more than replace my x with the value of 4, and it looks like we get 17 out. Fantastic. That problem is completed. All right, we are left with one little example down here, example C. And I'm just going to clear my board so that we can start with C. C will be a little bit more tricky as far as the algebra goes in it. Let's just start it out. F prime of x would be equal to the limit as h goes to 0. I need to evaluate this at x plus h, so there it goes in x plus h. Then I subtract 3. Wherever I saw an x, I replaced it with x plus h. Second part of this function is to subtract f of x, so there's x minus 3, all over h. We have the setup for our limit. Could I plug in 0? Well, no, that wouldn't work so well, would it? Because 0 would give me a division by 0, and that's not going to be super helpful. What we will want to do, and maybe you can remember back to chapter 1, how to work with limits with radicals in them. We will multiply this by the conjugate. So I'm going to multiply by x plus h minus 3 plus the square root of x minus 3 all over that same numerator, x plus h minus 3 plus the square root of x minus 3. What did we really do? Well, we did nothing more than multiply by a big fat 1. So how is that helpful? Well, let's go through the process here. We'll get the limit as h goes to 0. And I want to multiply the numerators together. And that's going to give me that times that, which a square root times a square root will make it a square. So I square the square root and it takes it out of the problem. My inners and my outers will be exactly the same term. I think I missed my mark there. Let me go back and grab first times first. gave me that x plus h minus 3. And now I want to do my inners and my outers. So here is the outer, here is the inner. Noticing one of them was a plus, the other's a minus, so they will add up to 0. And then we've got last times last, which will give us a negative root x minus 3 times a root x minus 3. That'll give me the value of the under the radical of x minus 3 all over h times the square root of x plus h minus 3 plus square root x minus 3. Okay, take a look at that. How can we simplify? Well, we can do some simplifying, and that simplification is going to look like x plus h minus 3, take and send the negative through. The bottom I would not want to send my h through, and you'll see why in just a moment. In the bottom I have a multiplication of two groups. Up on top, let's simplify. So we get the limit as h goes to 0. Simplification, negative 3 with positive 3 makes 0. Positive x with negative x makes 0. I get h over h times square root x plus h plus 3 plus square root x minus 3. I think that was a negative there. H minus 3, got it. This is great. The h's cancel, making 1. H divided by h is 1. And now, evaluating the limit, let's allow h to go in as 0. And this will become 1 over, don't need that anymore, square root x minus 3 plus x minus 3, because I took h to 0. And that gives me 1 over 2 radicals that were the same. My answer is f prime of x is equal to 1 over 2 square root x minus 3. That leads us to the homework. It is a puzzle sheet. And then the next one is day 2 homework. On the back side of that puzzle, there are 6 functions that I would like you to simply set up. I want you to try to get the derivative started. You do not have to take through and do the algebra part of it, but just please get it set up. So, you know what? Let's take number 3. It looks a little more difficult than number 1. All I need to do is apply the derivative definition. So f prime of x equals the limit as h goes to 0 of f of x plus h. So everywhere I see an x, I'm replacing it with x plus h. And here we go. We will have negative x plus h quantity squared plus 4 times x plus h. Minus, that took care of the x plus h. Now let's do the f of x, which is our function negative x squared plus 4x divided by h. That's all I'm asking you to do. You do not have to expand it, simplify it, or anything. You're ready to go on and do problems 1, 2, 4, 5, and 6. All right, I will post those as well to the Schoology page so you can print this homework.